Part 2 on circles. We're looking at the general form of a circle. So rather than that center radius form, which is generally the most common form you'll see, we have what's called the general form equation of a circle. So we want to be able to convert between them and also to be able to sketch a circle when our equation is given in this general form. So we know that it's not always going to be given to us in center radius form because life's never that easy. In order to convert it to the general form, what we actually are going to do is expand this equation. So remember, these are perfect squares, so they're not that difficult to expand. So x minus h squared is going to give us x squared minus 2xh plus h squared. And then we've got y squared minus 2yk plus k squared equals r squared. Now I'm going to rearrange this a little bit so that we group particular things together. So we've got x squared, and we're going to put the y squared with it. And then we have minus 2xh minus 2yk plus k squared, plus h squared plus k squared. And we're going to take the r squared over to make this equal to 0. Now, we refer to this because in our actual equation, obviously these are all going to be numbers. So when we have a value for h, that squared is going to be a number. So even though we can't simplify them right now as letters, as unknowns, once we have values for those, they would clump together. And we refer to this as c. So we're just calling it one big number. So what we end up with is x squared plus y squared minus 2xh minus 2yk plus c equals 0. And this is what's referred to as the general form of the equation of a circle. You can see I've got xh, they've written hx. Same, because again, h is going to be a number, so it's just going to be 2 times that number times x. So in order to sketch a graph of the circle when it's given to us in that general form, we really need to convert it back to center radius form because that's the easiest way to sketch a circle. To do this, we have to complete the square both for x and for y. So if you're not good at completing the square, now is your time to get really good at it. So to do this, I'm going to group my x's and y's back together. I know when we were rearranging, we just separated them all, but completing the square becomes a lot easier when you're working with things all together. So we're going to rewrite this as x squared minus 6x plus y squared plus 4y minus 12 equals 0. So we're going to complete the square of our x terms, which gives us x squared minus 6x plus 6 on 2 squared, so 3 squared. And then we need to take away 3 squared as well. Then we do the same thing for our y terms. So y squared plus 4y plus 2 squared minus 2 squared minus 12 equals 0. We obviously now have 2 perfect squares here. So we'll factorize those to become x plus 3 squared. We're going to take this minus 3 squared, so we're going to take our constant terms over to the other side to make life a little bit easier, so we'll ignore that for now. Our y terms simplify to y plus 2 squared, and then we're going to do our 3 squared, which is this term here, plus 2 squared plus 12. Simplifying that, so this side will stay the same, plus 2 squared. So we're going to have 9 plus 4 plus 12, which together is going to give us 25. And you can see now we're back in our x minus h squared plus y minus k squared equals r squared. So h is going to be negative 3, k is negative 2, r is 5. So our center is at the point negative 3, negative 2. Just realized in going to sketch that I've made a mistake. So these x terms, x squared minus 6x plus 3 squared, factorizes to x minus 3 squared. So this changes our value of h to positive 3. So obviously now that we've got a rough sketch of where our circle is, we know that we're going to have two x-intercepts and two y-intercepts. So let's start with our y-intercepts. Make x 0. So going back to our original equation is probably easier than the rearranged one, just because it's a bit less work. So we've got y squared minus 6 times 0, we can ignore that, plus 4y minus 12 equals 0. That's just a quadratic that we need to solve. So, I mean, really, you can just sort of solve that by inspection to say that we're going to have y plus 2 and, sorry, y minus 2 and y plus 6, because those two together multiply to negative 12, add to give you 4. So y is going to equal 2 or 6. We can chuck those points in there. So that's obviously going to be, sorry, negative 6, that would be. So that would be negative 6. Up here would be 2. We can then, there's a little more room, look for our x-intercepts. So I've got our equation. We would have x squared minus 6x minus 12 equals 0. That one's a little harder to solve, but you can, however you want to solve that quadratic formula, factorizing, you can't factorize that by inspection. I would probably go for the formula here, but what we end up with is x equals 3 plus or minus root 21. And it will work if you sub back into this formula. Sometimes that can be easier, sometimes it's not. You really just have to try things and work out what works for you. But all you're doing here is solving a quadratic. So obviously this point here, we've got 3 minus root 21. And over here, we'd have 3 plus root 21. The most important thing here is just that we can complete the square of x and y to convert between that standard form and the center radius form, because the center radius form is what you're going to need in order to sketch. It's almost impossible to sketch it by inspection just from that general form.